Alright, so we're going to start off our series on radical expressions and simplifying them with this very straightforward example. We want to simplify the square root of 54. So how do we go about doing that? First thing we want to keep in mind here is that 54 is factorable. That is, it's a composite number made up of a bunch of numbers multiplied together. And we're going to use that fact to see if we can get some cancellation to happen with this radical here. So what we're going to do is use what is called a factor tree, and this works as follows. You start with 54 at the top, and you try to think of two numbers that multiply to 54. In this case, 2 and 27 work. So sometimes the challenge is thinking of two numbers that multiply to the thing up top here. But as you break things down, it gets easier and easier. So 2 times 27 does indeed give 54. 2 cannot be broken down any further because it's a prime number. So we're going to leave that as is. In the case of 27, this can be broken down further into, say, 3 and 9. 3 can't be broken down any further because it's prime, but 9 can be broken down into 3 times 3. So now here's the important thing regarding this radical. This is a square root. So in order to get some cancellation here, we need to break our factorization up into products that have squares in them. So for example, we know that square root of 2 squared, because of the square and the square root, those cancel to give us 2, just for example. So if we can cluster all of our factors in groups of 2, we might be able to simplify this guy a little bit further. So how do we rewrite this? Well, here's a group of 2. We don't have any other groups of 2, so we can write square root of 54. That's going to be equal to 2 times 3 times 3 times 3, or 3 squared. So that breaks down 54, and now we have a radical expression that we can simplify more easily. But what we're going to do is we're going to use our exponent rule for when we have things multiplied inside a radical. So what that gives us is the ability to take this radical and break it up over every single factor here. So what this gives is square root of 2 times square root of 3 times square root of 3 squared. Okay? These don't simplify any further because 2 is not going to be a perfect square. 3 is not going to be a perfect square, so we're stuck with these guys for now. However, 3 squared, square rooted, just like the example I put up here, is going to cancel off. This is going to be equal to 3. So this gives us, carrying along everything that we've done so far, times 3. So the 3 is not inside a radical anymore. We canceled the square root with this square. All right, and you can do that with any power of 2 in the case of square root. So what do we do now to finish this up? Well, since this can't be broken down any further, I'll just put them back together. So this gives us radical 2 times 3 times 3, and then this is just going to be root 6 times 3. Again, that 3 is not inside the radical, so make sure you're very careful about drawing your radical bar only to the end of the expression that you want inside. Okay? If you want to rearrange this, you could put the 3 out in front. This is kind of what I typically do. So you have 3 times square root of 6. So at this point, this example is done.